Good evening, students. Very warm welcome on the next session of Solid State. Last time I have told you, students, that the unit cell can create the entire crystal lattice. If we repeat the unit cell, students, we will build the entire crystal. Is it right?
Yes, sir.
So the question was, rather than studying the entire crystal, it will be important that we study the unit cell of each crystal, student. Different crystals, different solids, they have different type of unit cells. So we should know what are the basic types of unit cells which exist, and therefore we will study the structures of these unit cells. And for that, we must know the parameters, the characteristics of the unit cell, because there are three edges, students: A along x-axis, B along y-axis, and
Y-axis,
C along z-axis,
Z-axis,
and three angles, students: alpha, beta, and gamma.
alpha, beta, gamma.
And when there will be variation in these parameters, we will get different unit cells. That's what we said. And we have shown you also that what are the ABC and where are the angles alpha, beta, and gamma.
Gamma, yes, sir.
After this, student, it was found out that there are 7 types of basically unit cells. How many? 7 types.
7 types.
Depending on the values of A, B, C,
And
alpha,
alpha, beta,
beta,
gamma.
and gamma, students. What we are saying, student, there are 7 types of unit cell formed. This is very important. Now there is going to be a question on that in every exam. What we have written here, student: cubic, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral, or trigonal, and triclinic. Probably in your books, when you study different inorganic chemistry, students, group of elements like sulfur, phosphorus, you may have seen that, okay, what we said, phosphorus exists in different allotropes and sulfur
Yes,
exists
sir.
in different allotropes. So you have seen such names: rhombohedral, monoclinic, or triclinic.
Triclinic, yes, sir.
And at that time, we told you when we will study the solid chemistry, we will be able to tell you more about these, that what is the structure of them, how they look like. And on the screen, student, we have these 7 unit cells. And it's very important that we should understand, student, what I have tried to show here. You see the first one, as you can see, student, the first one you can see on the screen, student. The first one is on the screen, as you can see. This one is cubic student. So tell me,
Yes, sir.
what is the edges? A is equal to B, B is
Is
equal to
equal to
C,
C,
and the three angles alpha
90 degree.
90 degree. I mean, they are perpendicular to each other. They are perpendicular to each other, student.
Together.
So what do you find, student? You have, these are the 3 axes, if you see in this, students. So what you are finding, students, that A is equal to B is equal to C. So you have A, students. Uh, if you, this is your x-axis, student, this is your y, and this is your z-axis, student, and then you have, this is A, student, and this side is B, students, and they are equal. They are saying the 3 sides are equal.
Equal.
Alpha is equal to beta is equal to gamma. So it's a perfect cube, student, perfect cube. We are going to give examples of each one of them to make sure that, okay, what type of, how do we determine that? We know by, there are many instruments now, X-ray, crystallography, and so many other methods by which we can see their unit cells. From cubic, student, we are going to tetragonal. Now we have to remember this or learn it slowly and slowly because they will give you one or two questions on that. Cubic to tetragonal, as you can see, what has happened here, student? What has happened? The A, B, and A is equal to B, but B is not
B
equal.
is not equal to C.
But angles are still alpha,
90 degree.
beta, gamma 90 degree. Tetragonal.
Gunal.
Tetragonal, student. Tetragonal will mean that one side C is not equal to A and B, as you can see. And but the three angles are still 90 degree, students. After this, there is a orthorhombic. Orthorhombic. Now, what is happening in orthorhombic? Angles are still 90 degree, but the three sides are now different. You can see alpha A is not equal to B, B is not equal to C. So, what is their student? If I say I started with C, then I'm going to tetragonal, orthorhombic, cubic, tetragonal, orthorhombic, CTO. Huh? In this, what you find? Angles are still 90 degree,
90
students.
degree.
The angle 90 degree still. Interesting thing to note down, certain things to remember. Alpha is equal to beta is equal to gamma 90 degree. So the angle A, B, and C will be changed. First, all A equal to B equal to C. In this, what will happen? A equal to B, B not equal C. So A in C, you are saying A equal to B equal to C. Then I come to T. In the T, you are saying A equal to B is not equal to C. Then you are going to orthorhombic. A not equal to B, not equal to C. Angle still same. This become one set. Okay. Next, you are having rhombohedral. Rhombohedral. I started with what I'm saying. Okay, I will put it here so that there is some way to remember them. Next is R, student. R. R is what? Tell me. R is what? Rhombo.
Rhombohedral.
In R, what is happening? A is equal to B, B is equal to C,
C.
but one of the angle is not 90 degree.
Not 90 degree.
What has happened? Alpha is
Is
equal to
equal to
beta,
beta. Is equal to gamma, but
gamma
not
is
90.
not 90 degree, student. That means you have just, if you have a cube now, you just push a cube from one side. What will happen? What will
The
happen?
angles will change, but the sides
Matlab,
will remain same.
yes, you have compressed from one side a cube, student. Rhombohedral, R. After that, student, is the next one? You are having hexagonal.
Hexagonal.
Hexagonal. In hexagonal, what happens? Again, what is the story? A is equal to B
B
and
is
B
not equal
not
to C.
equal to C. Two angles are
Alpha and
90
beta.
degree and
90.
gamma
Gamma 120.
120 degree, students. So hexagonal, CTORH, hexagonal. Hexagonal. After that, student, monoclinic. Monoclinic. What is happening in monoclinic? All the three sides unequal.
Unequal.
A is not equal to B, B is not equal to C, alpha is equal to beta is equal to 90 degree and gamma is not equal to 90 degree. Here gamma was 120 degree, but here gamma not 90 degree means
Not
it
90
can be
degree.
anything, not 90 degree. So monoclinic is shown here, student. The three sides are not equal monoclinic. And the last one you are on the board is triclinic T. So I have T here. What the T says? A is not equal to B, B is
Not equal
not
to C.
equal to C, and the three angles are also
Also not equal.
not equal to that. That is 1, 2, 3, 4, 5, 6, 7.
6. Yeah.
CT, CTOR, HMT, you can try to see some connection with something to remember it. And this is how we have to see. Because this learning is important. They will
Okay.
give you they will ask you that monoclinic, what are the values of the parameters? Then we have to show it. I mean, give it. That is the reason because these questions have been asked many times in the papers. Okay, student, seven type of unit cells. So if we will go in the books of chemistry, you will see their names. And there are examples of that. Let us see. Okay, examples of that, student. Examples of that. Once a table is given, it is important to understand and learn it because there is a question here. One question here. The cubic student, and we have shown you that what type of unit cells we have told you last time, student. Unit cells, how much type of unit cells we told you, student? Primitive or simple cubic, and we told you how many? BCC, FCC, and end centered. End centered. Now, out of the seven which we have shown you, which one they will show, that is important because they can be BCC, FCC, or they can be primitive, but not every compound or every element cannot show. You see all these
Yes.
FCC or simple cubic. Experimentally, they find out their unit cell structures.
Okay.
And in the cubic, student, what are the possible variations? What are the possible variations in the cubic? As first thing here, I have written cubic. In the cubic, student, we have primitive, body centered, and face centered. So how many you have? One, two, and three possibilities. So you have A equal to B equal to C, alpha, beta, gamma. Examples of this are cubic. Examples of cubic unit cells are NaCl is cubic, zinc blende is, and copper. These are the examples. If you want to see more details, you can check it in the books.
Yes, sir.
They will show the structures of these compound, students. Uh, Whatever is required, we will show you. More information is available for students who want to go into more detail in this chapter. As I said, this chapter will involve imagination and visualization. Three-dimensional pictures have been shown at many places, student, and one wants to see it, they can see it. Tetragonal, what do you find, student? It is tetragonal are existing in primitive and BCC, not in FCC. So here
Okay.
how many? One and two.
2.
And these are the axial distances, these are the axial angles. They are going to be asked in the paper, students. A is equal to CTOH RMT. Okay? So here A is equal to B, B not equal, three angles equal. Example, white tin, TiO2, CaSO4 are examples of the tetragonal unit cells. Orthorhombic, there are four possibilities in orthorhombic. How many? One, two, three, and four, students. Four possibilities in orthorhombic. Two possibilities, three possibilities. A is not equal to B, B is not equal to C. Angles alpha, beta, gamma 90. Example, rhombic sulfur. In the case of the sulfur, we told you when we were studying the allotropes of sulfur, rhombic sulfur. Potassium nitrate, barium sulfate, students, you can see their structures in the books where they have given certain three-dimensional images of these. Hexagonals showing only one primitive. This is our hexagonal student. And A is equal to B not equal to C, alpha, beta 90, gamma 120 degree, graphite. You have seen the structure of graphite in the books a lot.
Yes, sir.
What was it look like? Sheet-like structure, hexagonal.
Yes, sir.
ZNO and cadmium sulfide. Cadmium sulfide also. You see, they are existing in primitive hexagonal structures, hexagonal unit cells. Rhombohedral student or trigonal, this is only one. And A equal to B equal to C, alpha, beta, gamma, not 90 degree. Calcite, you know, CaCO3. CaCO3,
Yes, sir.
very important. Calcium, which contains calcium, students. And cinnabar is a very important ore of mercury. But it has rhombohedral or trigonal unit cell. Then monoclinic has got two students, one and two. Monoclinic two. A not equal to B, B not equal to C, alpha, gamma 90 degree, beta is not. Monoclinic sulfur. In the sulfur, they have given an example of sulfur allotrope student. We have discussed the allotrope of sulfur, rhombic and monoclinic. Sodium sulfate with 10 water molecules, students. And triclinic, again, only one primitive. A not equal to B, not alpha not equal to beta, not. Example, sometimes example will be asked student, at least that information which is given in your NCRT books should be learned.
Okay.
And beyond that, I am not saying that you can learn some, all the, that will not be asked. At least
Okay.
any word which is written in NCRT could be asked as a question. Students, be clear about that. So copper sulfate, you see blue vitriol, 5H2O. What is copper sulfate? Blue vitriol. This potassium dichromate, you are aware. H3BO3, you are aware, students. These are important compound. How many total it comes, students? How many total? How many are these? 3, 2, 4,
One,
1,
one,
1,
two,
2,
and one.
and 1. How much is this? 3 and 2, 5.
14. 14.
5 and 4, 9, 10, 11. So 14 student total possibilities. And you know, a mathematician named Bravies. Mathematician named Bravies student, you have heard about that important point. Bravies was a mathematician student and he has French mathematician who defined the crystal lattices and he said there are 14 possible three-dimensional lattices. He mathematically he said that there are 14 possible, mathematically how many? 14 possible
14.
three-dimensional students, ठीक है, three-dimensional lattices. Question have been put somewhere about Brevis also. See the interesting thing. The nature works how. Mathematically, I can draw the possible variations. And in nature, what we find, it actually happens. Those compound students, when they are crystallizing, what type of unit cells they can take. And within 7 unit cells, where the variations are possible. How many type I told you? Primitive, BCC,
BCC, FCC, and end centered.
and centered. Everything to be learned, student. How many total possibilities? 14. Okay. 14 brevis lattices. Okay. Here is what we are saying, student. Crystalline materials fit into one of the 14 recognized lattice arrangement. These are called brevis lattices. And to honor the mathematician brevis student who has given the crystal lattices, you see that in chemistry we use a lot of math student, lot of physics wherever possible. Because we want to give representations to these students. How will we represent these? And as I said, this involves visualization and imagination. So everything is inside the crystal, students, and we are trying to explain it on the paper. So we are making points three-dimensional and making going to do many calculations which will fit into the experimental results, and we'll be using the simple type of maths. We don't use very complex maths, and when a very complex maths comes, student, we say, okay, we are not going to do the such derivations, but we are going to tell you the result, student, as we told you about the four quantum numbers which were
Yes, sir.
derived from the Schrödinger's wave equation, the
Yes,
solution
sir.
of the state of the electron in an atom was described as four quantum numbers, and how well we are using to write the electron distribution of different elements, those rules which were given. So here, primitive cubic, one, two body centered cubic, three face centered cubic, four primitive, five. We are saying there are how many possibilities? Primitive body centered, face centered cubic, primitive tetragonal, body centered orthorhombic, body centered or face centered orthorhombic, primitive base centered, and like this. So the maximum number of variation is shown by which one? Which unit cell is showing the maximum variation, students? 4 was shown by which one? Orthorhombic.
Orthorhombic.
This question has been asked student in the paper. Ortho,
Rhombic.
orthorhombic, student. This orthorhombic can exist in primitive
Face centered, body centered, end centered.
BCC, FCC, and centered. So four possibilities. So orthorhombic will show the maximum variation, and orthorhombic is important then for the paper. That means A is not equal to B, is not equal to
Not equal
C,
to C.
and alpha is equal to beta is equal to gamma is equal to 90 degree. This is the way I write, because I will forget myself also. And certain, always certain numbers where something is more or less, student, they are always in question or demand. Something is existing in different state under room temperature is in demand, is in question. So all this we are aware of that. When we were studying the inorganic chemistry, something which exists highest oxidation state, lowest, strongest oxidizing agent, reduced, all this, wherever certain important points come, they become questions in the paper, student. Here is a picture of these students which have been shown: cubic, tetragonal, four orthorhombic lattices, orthorhombic lattices, unequal sides, angle between faces 90 degree. See, orthorhombic, again and again it is coming. They become important, student. They can ask you that which unit cell has got three sides unequal and three angles 90 degree. Any type of question can be there. Monoclinic, students, and rhombohedral, students, hexagonal lattice, These pictures are available in different books, students. Those students who want to see more, they can see that. And three-dimensional cubes will be drawn a lot in this, just for visualization, where the you can see where these particles are present, student atoms are present. You can see a small part of it becomes a unit cell, but these are we are only a representation. These atoms are joining actually as close to them as possible. You know that we are showing only as points because they are not they are when they will be packed students, they will be touching wherever possible is possibility is there. So in order to understand, we have simplified this because we want to
Okay.
make certain calculations and understand students. Okay. The next question which is asked in the paper, student, is a number of atoms in a unit cell, which is also called the rank of a unit cell. Number of atoms, student, in a unit cell. This is also called the rank of the unit cell, student. Rank of the unit cell. How will we calculate the rank of a unit cell, students? देखो first one we told you primitive cubic cell, student, or simple cubic, primitive or simple cubic, student. First one is that what we told you, simple cubic or primitive one, student. So what will be the rank of the primitive cubic unit cell? First one we have primitive unit, primitive cubic unit cell, students. Simple cubic, this is also simple cubic, SC. Now in simple cubic, tell me where are the particles located?
At the corner.
At the corners. Okay, second point. Atoms are only at 8 corners.
Yes, sir.
How many corners are there?
8.
8 corners. ठीक है? Of the cube, student. You are sitting in a room. Any doubt is there? You can see the room in which you are sitting. How many corners the room has? I am
8.
also sitting in a room. I when I first time I didn't understand, so I was looking at the room sides. Four on the top, four on the bottom. Okay, all three-dimensional picture but has been drawn to show you, students. This is you can see 1, 2, 3, 4, 5, 6, 7, 8. Okay? Actual story is like this. What is the actual story? They are touching. See, they are touching.
Yes, sir.
Here we are showing because some students have doubt, student, that what is they are farther away. They are not farther away, students. They are actually packed like this.
Okay.
But to make a representation more easy and understand, so we have made it like that.
Okay.
So it comes to A, B, and C part, student. What do you mean by rank, student? That what is the number of atoms per unit cell, student? Number of atoms per unit cell. Atoms we are taking as spheres. Spheres, they are hard spheres, student. If atoms are not hard, what will happen? Can one atom penetrate into another?
No, sir.
Maximum they can touch.
Yes, sir.
No atom is going into another atom, student. They are only touching. If possible, somewhere they may not be touching also. Depends. So, students, what is the contribution? This is my third point. What is the contribution of each atom at the corner, each atom at the corner, student. This is a unit cell. This is a one unit cell, student. Each atom on the corner, what it is its contribution, student, in the unit cell?
Uh,
How many?
1/8,
देखो,
I
this is
think.
as I said, visualization है. Consider the room and see the corner of the room. How many that this room is joined by how many rooms on the same your room? Left side, two on the other side, and on the top of this also. When you will build a crystal structure, student, there will be layers, students, of the unit cells. What layers? For example, now here is a story. See, this is a one unit cell, student. ठीक है? Can you see that?
Yes, sir.
This is the atom, student. And what is the happening? This unit cell. There is another one here. There is another on the back. Two. How many are there? One, two, three, four. And four on the top of this. ठीक है?
Talk.
So if I see the
Yes, sir.
part, student, here, then it is 1/8. Only 1/8 part of the atom. 1/8 part of the atom is, student. Only 1/8 part of the atom. Only 1/8 part of the atom. Only 1/8 part of the atom is present, student. Only 1/8 part of the atom is present in this. How much? Only 1/8 part. Clear?
Yes, sir.
Only 1/8 part is present. So if only 1/8 part is present, how many corners are there? 8. The contribution of one corner is 1/8. Each atom at the corner contribution 1/8. So total, how many? Total contribution, students. 1/8 into 8, student. How much will be that? 1. So
8 into 1/8.
what is the rank of the simple cubic? Simple cubic, or simple, what we call this as a unit cell, student. What will be the rank of this?
1.
1. So the rank of this is 1, students. So the rank of the simple cubic unit cell is 1. And you can see this is the simplest case we have taken, students. Simplest case. Any doubt here?
No, sir.
This is also called a primitive unit cell. Primitive unit cell. Next, students. Next, I am coming to the body-centered cubic units. What is the body-centered cubic unit cell, students? What do you mean by body-centered? We have told you in body-centered, in body BCC, student, you have 8 atoms
At the corners
and
and one at the
8
center.
corners. ठीक है? 8 atoms at 8 corners, students, and you have one atom
One atom at center.
at the body of the cube. What we call as at body
Body of the cube.
That is inside the cube, student. At the body which is inside the cube. So one atom is at the body or inside the cube. Eight atoms at the eight corners and one atom at the body which is inside the cube, students. So students, eight atoms at eight corners, one atom at the body, and then we have to calculate the rank, student, or we have to calculate the number of atoms per unit BCC, student, per unit BCC. So what will be the value of that number of atoms per unit BCC? So if we want to calculate that, students, what what is the contribution of eight atoms at eight corners, student? 1 by 8 into 8, student, how much is 1? Second, what is the contribution of the atom which is inside the body of the cell, student? Contribution
1 into 1.
1 body center atom. Contribution of 1 body center atom. You can see that this atom I have shown like this here. Actual story is like this. Now this is the body, one is touching the other two corners. See, this is the body. So it is inside the unit cell, the whole unit cell. It is not shared by any other unit cell. It is not shared by any other unit cell. Is it? No, it is not shared by any unit cell, students.
Okay.
So the contribution is 1. So what is the total number of atoms per unit cell, student, for BCC? 1 plus 1 is 2, students. 1 plus 1 is 2.
2.
So the rank for the BCC, rank for the
Is
BCC
2.
is 2. So BCC rank is 2, students. For any BCC, you will see the rank is 2. This is the actual state. You can see that once it is like this, these corner ones are touching. See this corner, the atoms which are at the corner, student, they are touching.
Okay.
This is the line. They are touching. Once they touch, these may not be touching completely. There will be some gaps here. That is the thing, because this is inside that. So there will be some gap, student. There will be some gap. Interesting thing. All right. The next one is, student, which is the next one is FCC student. In FCC student, which is our face-centered cubic cell. Face-centered cubic
Unit cell.
unit cell. And in face-centered cubic unit cell student, first you have 8 atoms
At 8 corners.
at 8 corners student. ठीक है? 8 atoms at the 8 corners student of the unit cell. And second, how many faces are there?
6.
Okay, if I have 1, 2, 3, 4, 5, 6, I'm sitting in a room, I'm counting that 6 faces of the cube. There are 6 faces of the cube, and at the center of each face student, what you have? One atom. At the center of each face, you have one atom, students. And that atom at the face, what is the contribution of 8 corner atoms, student?
1. 8 into 1 by 8.
8 into 1 by, that is 1. What is the contribution of the atoms at the center of each face? What is the contribution of atom, students? What is the contribution of 6 face centered atoms? See that this is the one which we have shown here. This is at the center of the face. Consider the room and the wall. At the center of the wall is an atom, student. Then it will be shared by how many unit cells? How many unit cells will be there with which it will share, student? The one which is at the face.
Yes.
How many?
1 by 2. 6 into 1 by 2.
This you can have, if there is a unit cell, there is another one here, that's all. So half will be on this side and half will be on this side. Okay? You can see that. Half. Okay? Half will be on this side and half on the other side. So the phase 1 is shared by 2 unit cells. The atom at the center of phase is shared by 2 unit cells. That atom at the center of the face is shared by 2 unit cell, students. So what will be the result of that, student? The contribution of each is half atom per unit cell for face centered atoms. For face centered atoms. So what you will get? 6 into 1 by 2. How much will be that? 3.
3.
So what is the rank? Total, ठीक है, number of atoms per unit cell for
Is
FCC.
4. 4.
4. So you have 4 atoms per unit cell in the case of FCC. ठीक है? And
Yes, sir.
Therefore, as you can see, once this is here, this is touching this corner and this corner. And there is a gap now between these two because this is the line, student. Here the atoms are touching. And this is a picture of this. See, they have come in the center of the face. Student, if you take this side of the face, so you can see that how there is a, this is our center of the face. Student, this they are touching. This they are touching. See that? So three types of the cells which we have told you, student. Simple this and okay. Any doubt here? Is there any doubt?
No, sir.
For example, a question is give the significance of the unit cells. Give the significance of a lattice point, student. What is your answer, students?
Sir, lattice points significance.
1 mark question. The same question can be put in objective type form also.
Sir, each lattice point represents one constituent particle
That is
of a
okay.
crystal lattice.
So what is the significance of that, student? What is the significance of the lattice point, student? Why do you need lattice points?
Sir, by joining these lattice points, we can bring out the geometry of the molecule.
So each point in crystal represent one constituent particle. ठीक है? Lattice points are joined by straight line to give the geometry of the lattice. Next question on the screen, student. Name the parameters that characterize the unit cell.
Its length along the three edges A, B, C, and the three angles alpha, beta, gamma.
Along x-axis, along y, along z, and alpha angle is between. You can.
Alpha is between B and C.
Beta angle.
Beta is between A and C.
If I hide this. Gamma.
Between A and B.
A and B. Okay, students. Distinguish between hexagonal and monoclinic unit cells. Now the question comes, how will you distinguish? What is the difference between you have hexagonal and monoclinic?
Sir, in hexagonal, only one variation is possible, primitive. And in monoclinic,
That variation is not required here. Give me the parameters. He has not asked a
for
variation.
hexagonal, it is A equals to B, not equal to C. And for angles, it was alpha is equal to beta is equal to 90 degree. And gamma is equal to 120 degree.
Gamma is equal to
90 degree.
huh?
120, gamma 120.
And monoclinic?
For monoclinic, A is not equal to B and not equal to C. And for angles, it was alpha is equal to gamma is equal to 90 degree.
Alpha is equal to gamma.
Yes, sir. And beta was not equal to 90 degree.
alpha is equal to beta and gamma was not equal to 90 degree. Monoclinic, monoclinic, what we said, alpha is equal to gamma is equal to 90
90
degree
degrees.
and
Beta is not equal to 90 degree.
okay. What is the distinguish between face centered and end centered?
Sir, in face-centered unit cell, one constituent particle is present at the center of each face, apart from those present at the corners. And in end-centered, the constituent particle is present at the center of any two opposite faces, apart from the ones present at the corners.
Okay, explain how much portion of an atom is located at one corner.
At one corner is 1 by 8.
Body centered, center of a
It's
cubic
1 body center 1.
one. Okay. You can see that there will be questions on these variations in the type of the cells which we are talking, students. Okay, then we are closing this topic here because we have to begin the next fresh topic, which will be a complete lecture on this, and we will take the packings, closed packings, one dimensional, two dimensional, and three dimensional in the next lecture. Here we are trying to show you what type of questions can be asked students, objective type, assertive, or other type of true or false. Anything can be possible now. So more objective types are expected this year, and therefore you have to be very careful in understanding each and every part. Okay? Okay,
Yes, sir.
then good night. I will see you in the next lecture, which will be on packing,
Okay.
closed packing structures. We'll see what type of closed packed structures are possible, and we'll try to work out some more questions. Okay, then we'll see you in the next class. Good night.
Okay. Thank you, sir. Thank you, sir.